This is the third method, which is known as halogen exchange method. Halogen exchange. Now we have two parts here. One is Finkelstein reaction and the second is Schwartz reaction. So we are going to talk about the first one, Finkelstein reaction. Now see, what is Finkelstein reaction? Basically, there will be halogen exchange, and this halogen exchange and Finkelstein reaction is all about preparing iodoalkane, iodo only for alkyl iodide. So I'm going to write with me, alkyl iodides are often prepared by reaction of alkyl chlorides or bromides with sodium iodide in presence of dry acetone. Dry acetone. And this is also known as name reaction, and this reaction is known as Finkelstein reaction. We can write. This reaction is known as Finkelstein reaction. Now suppose this is Rx and X only stand for bromine, chlorine and bromine. X only stand for chlorine and bromine that reacts with sodium iodide, and there will be halogen exchange like this. NaX salt will be halogen exchange. X sodium of sodium will come with R, that is alkyl iodide, plus NaX. This NaX is byproduct. Please write this.
Yes, sir, finish.
Everyone done with this? Fatima, Hamza, Sneha. Hamza and Sneha. Okay, everyone done. Now see, the second method is known as Schwartz reaction. B is Schwartz reaction. And this is all about preparing alkyl fluorides, Schwartz reaction. So how this is also halogen exchange. So I'm going to write the reaction first. If you have CH3Br and you are going to use a salt like AgF, there will be halogen exchange. This halogen will come to this and this halogen will come to this. So it will be CH3F, alkyl fluoride, or you can say methyl fluoride or fluoromethane, and AgBr will be out. Now we can write the synthesis of, especially alkyl fluoride, the synthesis of alkyl fluorides is accompanied by heating an alkyl chloride / bromide. This is also for chlorine and bromine. There will be halogen exchange with fluorine in presence of a metallic fluoride. In presence of a metallic fluoride, such as this metallic fluoride is basically can be like AgF, or we can write Hg2F2, AgF, Hg2F2, COF2, or SbF3. And this reaction is known as Schwarz reaction. This reaction Schwarz reaction. Please write it.
Yes, sir. Finish.
Hamza, Fatima. Very good. So this is all about the preparation of haloalkane. Now let me check. Very good, Fatima. If anyone have any doubt, please ask me. Now going to give some questions regarding this. Okay, write a question. Draw the structure of major product. Major monohalo in each of the following reactions.
Sir, the first one is OH will be replaced by Cl.
Very good. What will be its IUPAC name?
One cyclohexane.
Cyclohexane. Very good.
Sir, the second one, the OH down is going to be replaced by Cl.
Which OH? This one or this one? First or
The
second?
first one.
The first one. It is directly connected to benzene, so it will not be replaceable so easily. Only not given by heat. See,
Yes,
this
sir.
is benzene, and if something is connected to directly benzene, it is not that easy to remove it. So it will be easy to remove this OH because it is out of the benzene, connected, not
Yes,
directly
sir.
connected
Okay.
to benzene. So the product will be like this, CH2Cl. Got it? And the product of
Yes,
this
sir.
will be like this, which, since this is not benzene and not aromatic compound, this benzene is basically aromatic compound which is very stable. So this will be like this. Next, we need to the measure product. Can you do this? See, there is basically halogenation, UV light in the presence of sorry, Br2 in the presence of UV light or heat. So there will be halogenation. So this is benzene, which is aromatic, and NO2 is directly connected to this. So it is not replaced by this. And there is two probability. CH2Cl, that means this product, and chlorine can also be added to like this. So you have to decide now which one is more stable, this one or this one. Nafisa, which one is more stable?
The second one.
Second one, because it's 2 degree and this is 1 degree. That's why this is
Yes,
the
sir.
major product and we need to only write this product.
Yes, sir. Okay.
Okay. Okay. Everyone done with this? If you have any doubt, Hamza, why are you not responding? Okay, Sneha and Fatima. Okay, next question, right? The next question. This is very important question. Take your time, but do it correctly. And it's very easy. Please do this.
Are you lagging behind on the
Nafisa, are you done with the first one? This fourth question.
No, sir.
What is your answer? Fatima,
I don't know,
Sneha.
sir.
So this is very easy. If you have, that means you haven't revised the previous notes, previous classes notes. See, this is hydrogen halides. Can I call it hydrogen halides? And this is alkene. So you have to remember it will be either Markovnikov and anti-Markovnikov. Since there is nothing written on the arrow, that means it is in absence of peroxide. That means this is Markovnikov. And what does Markovnikov says? Negative part of the addendum will go along the double bond to the carbon which has lesser number of hydrogens. So you can see this has hydrogen 1 and this carbon has does not any hydrogen. So go and break this double bond and this is CH3. So Br will go to I will go to that carbon which has lesser number of hydrogen, and hydrogen will go to that carbon which has greater number of hydrogen. So hydrogen will come to this. So the product will be this 1 iodo 1 methyl cyclohexane. Is that clear, Nafisa?
Yes, sir.
Please write it. What about the fifth one? Fifth one is so easy.
Sir, Na will be below CH3.
So this is basically Finkelstein reaction. You can see. So the product will be CH3 CH2I and then NaBr. Yes or no?
Yes.
Okay. Do the sixth one. Can you do this reaction?
Sir, it would be um there will be Br
What
on
will
the second,
this or this?
this
Please
the
name the compound.
two comma 4 bromo
No. See,
cyclohexane.
not it will be not cyclohexane because this is halogenation. And in halogenation, whenever this is Br2 in the presence of UV light, we just break the single bonds carbon, not double bonds. See like this CH3, CH2, CH3, and reacting with Cl2 in the presence of UV light. What happens here? Chlorine will go to this carbon, middle, or this, like this. Chlorine
Yes,
will
sir.
go to this carbon. So in the same way, this chlorine will not break the double bond. Double bond will be like this. Chlorine can go here. Bromine. So this is the product. 1, 2, 3. So that means 3 bromo cyclohexene or hex 1E. So you have to remember what is its reagent, what we are going to use according to that reaction. You have to see what which type of reaction is this and what you have to do. If the same reaction is given like this, just feel the difference. your Cl2 ले लीजिए in the presence of CCl4. So what you need to do is just break the double bond and it will be ClCl here. Are you getting my point?
Yes, sir.
Please write it. Let me know when everyone done with this. Then we are going to start
Yes, sir.
preparation of Awareness. Everyone finished with this? Fatima, Hamza, and Sneha. Okay. Now write a topic. Preparation of Haloarenes. So see what is how we are going to prepare Haloarenes. So since this is arenes, that means benzene, so we are going to take a benzene type compound in reactant. So the first preparation comes from hydrocarbon by electrophilic substitution reaction. Electrophilic substitution reaction. So everyone knows about electrophile and nucleophile, yes or no? You have studied it in class 11th. Electrophile, that means electron lover, and nucleophile, that means nucleus lover or positive charge lover. So basically, this electrophiles means electron deficient compound, electron deficient, electron poor compound, and this nucleophile means electron rich compound. So the one which is electron rich compound will go to the compound which has electron deficient, which is electron deficient. So this is basically electrophilic substitution reaction. There will be electrophile which will attack or substitute in reaction. So according to this, there is I'm going to take methyl benzene first. This is methyl benzene. I'm going to react this with X2, that means halogen, in the presence of C, iron and dark. Dark, this means basically cold. That should not be hot water, that should be cold water. The temperature should be like 0 degree or somewhere 0 degree, about approximately 0 degree. So there will be two product formation. The first one is with respect to CH3, it will be on what this position is called, ortho meta para. This is ortho, and there will be another product that is on para. This is on para. So meta X does not go to meta because there is no charge during resonance on X. There is no charge on benzene during resonance on position this meta. So first of all, let me know, do you know about ortho, para or meta?
No,
If
sir.
you don't know, yes or no, Nafisa?
No, sir.
No, sir. So see, this is benzene, and with respect to any group, just suppose this is X, this position is ortho. With respect to this position is meta, and with respect to this position is para. That's why I wrote, I told you this is ortho and this is para, and this is with respect to this is meta. So this will have a name, halotoluene. Halotoluene. This is para, P for para, halotoluene. So always remember this. This is with respect to this is ortho, this is meta, this is para. When, do you know how to do resonance? Can you draw resonance structure? Yes or no?
No, sir.
Very good. So please write it.
Yes, sir. Finish.
Everyone done with this? Nafisa, Sneha.
Yes, sir. Finish.
Now see, synthesis, it is giving two products. So how we are going to separate this ortho and para? So there will be very large difference between their melting point, and we can easily separate it out. This X is easily X is this method is for chlorine and bromine. For iodine, we need oxidizing agent, and for fluorine, we cannot prepare fluoroarenes. This cannot prepared by this method. So we need some. There is some note you have to write, which is very important. The ortho and para isomers can be easily separated due to large difference in their melting points. Due to large difference in their melting points. Next point, which is very important, reactions with iodine are reversible. So everyone knows about what is reversible reaction. I will ask it. Reversible in nature and require the presence of an oxidizing agent, HNO3 or HiO4, which is an oxidizing agent, and it oxidizes HI formed during iodinase. There is another point for fluorine. Fluorocompounds are not prepared by this method due to high reactivity of fluorine. So this is how we prepare Haloarenes.
Yes, they're finished.
Sneha, are you done with this? Hamza? Okay, write it, Sneha. Done. Very good. Now see, second methods of preparation of haloarenes is from amines. Do you know what is amines? There is a chapter in this book, amines, from amines. And this amine, from amines, we prepared it by Sandmeyer's reaction, also known as name reaction. Sandmeyer's reaction. So now see, amine is basically this is amine. NH2 directly connected to a benzene is called amines. So how we are going to prepare? So there is amine, and we are going to react this amine with nitrous chloride. With nitrous chloride, that means sodium nitrate, nitrite in the presence of HX. This is nitrous chloride, nitrous acid, you can say nitrous acid at cold temperature like 273 to 278 Kelvin, 0 to 5 degrees centigrade. So we will get a disonium chloride salt. So it will be basically N2 plus X minus. This is known as benzene disonium. Disonium is also a functional group, disonium. And since this is X, so I'm going to write halide. And this benzene disonium halide, N2 plus X minus, will be passed through or react with Cu2X2, and it will give you directly a benzene halide. X plus N2 will be evolved. This is known as aryl halide as common name, and there is X is for chlorine and bromine. For iodine, we just need to prepare only this benzene disonium halide and shake with Ki, potassium iodide, and we will get directly iodide, iodobenzene. So please write it.
Sir, what's the last one below the product?
Product is this. It is in
Yes, sir, what's
two-step
below
reaction.
that? The word below that.
Aryl halide.
Okay, yes, sir. Yes, sir, finished.
Everyone done with this? Sneha, Fatima, Hamza, Disonium. This N2 plus X minus disonium. Group by iodine does not require the presence of cuprous halide and is done simply by case of preparing iodobenzene. So this is the disonium N2 plus X minus. You are going to react this with potassium iodide and it will give you directly iodobenzene. Please write this.
Yes, sir, finished.
Very good. Hamza, you are also done with this. Now see, I'm
Yes,
going
sir.
to give very arrange following in increasing order of dipole moment. From the knowledge of class 11th, you can easily do this. So this is CH2Cl2. This is CHCl3. This is CCl4. A, B, and then C. Can you do this?
Sir, it's already in order. CH2, Cl2,
Which one
CHCl3,
will
and then
have which one will have the highest dipole moment? This
yes, sir, the last one.
last one, you know, the dipole moment of the last one will be 0. That means it is in negative, right? See what happens here. If you are going to check it, it will be like this is basically tetrahedrally arranged. Tetrahedrally, that means 2 in the plane and 2, 1 out the plane and 1 inside the plane. And this will be like Cl, Cl, H, Cl, and then H. And then CCl4 you can see. For understanding only, I'm going to explain in 2D. Now you can see dipole moment, that means there will be electronegativity difference. So chlorine is more electronegative. This chlorine is also more electronegative than carbon. This chlorine is also more electronegative than carbon. This chlorine is also more electronegative than carbon. Now see, this both are in opposite direction, that will cancel each other effect. Yes or no, Nafisa?
Yes, sir.
In the same way, this will cancel this its effect. So mu will be equals to 0. Yes or no?
Yes, sir.
Now you can see chlorine is more electronegative than carbon. Chlorine is more electronegative than carbon. Chlorine is more electronegative than carbon. And hydrogen is less electronegative than carbon. Yes or no? Can I write it like
Yes,
this?
sir.
And if
Yes.
you are going to talk about this, like this will be like this will be like this will be like this. Now you can see. So you can see this and this will cancel each other. But these
Yes, sir.
both are in same direction. These both are in same direction. These two are both in two are in the same direction. So this answer will be CH2 Cl2 will be highest, then CHCl3, and then the last one CCl4, because it has dipole moment equals to 0.
Yes, sir.
Samjha, Neha? Please let me know if you have any doubt.
Yes, sir. Finish.
Are you done with this? Okay. Next question is, this is very important question. A hydrocarbon C5H10 does not react with chlorine in dark, but gives a single monochloro compound C5H9Cl in bright sunlight. Identify the hydrocarbon. Identify the hydrocarbon. The question is very easy if your basics are strong. Nafisa, can you do this?
Yes, sir. The answer is C5H10 because it's an alkane. Because it's not an alkane.
It's not an alkane. So what it is?
It's a cycloalkane.
So alkane, that means it's a cycloalkane, no? That means it's alkane. You told me it's not an alkane, it's cycloalkane. At the end, there is alkane.
Yes, sir, but isn't it like shaped differently? I don't know.
Now see, basically monochloro compound, single monochloro compound. First of all, this alkene cannot react with chlorine in the presence of alkene cannot react with chlorine in the presence of you can say basically UV light, alkene directly. So this compound is cycloheptane. Only alkane reacts. So this is cycloheptane. If you are going to react this Cl2 in dark, no reaction will take place because it requires some energy to break hydrogen carbon bond and add chlorine to the carbon. And if you are going to react this chlorine in the presence of sunlight, chlorine in the presence of sunlight, that means UV radiation, it will form a monochloro product because anywhere if you are going to add chlorine at any position of the this compound, you will get the same compound. Are you getting my point? So this is the
Yes, sir.
compound hydrocarbon. This is cyclopentane. The hydrocarbon is cyclopentane. It is also an alkane, but its structure is cyclic compound it is. Oh, let me know when you are done with this. Are you done with this?
Yes, sir.
Okay. So the next question is, write the isomers of compound having formula. I have already given the same question, almost same question, similar question previously. C4H9Br. Please write all the structural isomers of this and let me know.
Sir, the first one is CH3, CH2, CH2Br, bromobutane.
Yeah, it's very easy. First one, in name you should name the compound. 1-bromobutane, right?
1-bromobutane, yes, sir. And then 2-bromobutane.
Then 2-bromobutane, very good. So you are going to write it like this, 2-bromobutane. And the third one,
1-bromomethylpropane.
1-bromo-2-methylpropane, right?
Yes, sir. Yes, sir.
1-bromo-2-methylpropane. And the fourth one, 2-bromo-2-methylpropane, right?
Yes, sir.
So everyone write its name, please. 1-bromobutane, 2-bromobutane, 1-bromo-2-methylpropane. Third one, 2-bromo-2-methylpropane. So it's very easy, I think. Everyone done with this? Sneha?
No, sir.
Okay, please do it.
Yes, sir. Finished.
Very good. Fatima, are you done with this? Write the equations for the preparation of 1 iodo butane. First one, we need to prepare 1 iodobutane from 1 butanol. The second is from 1 chlorobutane. We need to prepare 1 iodobutane from 1 chlorobutane. And the third one is but1. Please do this question. It's very important and easy. Mm.
Sir, how to do the first one?
Sir,
Yes.
um, in this we'll we'll add iodine to the first one with the help of hydrogen, right?
No. See, we what we need to do here. We need this is reactant. This is reactant. We need to prepare this from this. That means I'm going to write in equation 1 butanol. 1 butanol. That means CH3, CH2, CH2, CH2. This is 1 butanol. Yes or no? Is this 1 butanol? Speak up.
Yes, sir.
Now see, and what we need to make this 1 iodobutane. That means this is CH3, CH2, 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 I. Yes or no? So what you need to do
Yes,
is,
sir.
if you are going to add this Hi in the presence of ZnCl2, or there are other methods like px3, you can use iodine, bromine was there, px5 you can use. So this iodine will replace OH, yes or no?
Yes, sir.
And we don't deal with byproduct. So this is how we are going to prepare it. Okay, Hamza.
Yes, sir.
So this was the first. Now do the second and third is very easy.
Sir, the second one is
Sir, we'll add
CH3.
Yes.
sir, we'll add
Chlorobutane.
Ki as the reagent.
Yeah. Ki, what is Ki? Ki, potassium
Potassium
iodide.
iodide, yes.
This was used in Sandmeyer's reaction for chlorobenzene and iodobenzene.
So we can use this in butane also.
Wait a minute. Chlorobutane. One chlorobutane was like this: CH3,
Yes, sir.
CH2, CH2, Cl. And what we prepared? One iodobutane, right? So CH3, CH2, CH2, CH2 iodobutane. So what you need to do? Finkelstein reaction, NaI in the presence of dry acetone. We just studied Finkelstein reaction. Yes or no, Hamza?
Yes. Acetone with Ki.
Yeah, that is yes. NaIKI. Okay, in the presence of dry acetone. Got it. So this is NaI. Done with this. But 1 in.
Yes, sir.
What is the reaction? From but 1 in to we need to prepare but 1 in. CH2 double bond, CH single bond, CH2 CH3. This is but 1 in, and we need to prepare one iodobutane CH3 CH2 CH2 CH3. Just what you need to do: CH CH2 and iodine. Now see, if you are going to add HI in absence of peroxide, that is Markovnikov. So I
Yes,
will
sir.
go to this, but this must be peroxide. In the presence of peroxide, in presence of peroxide, that means anti-Markovnikov, anti-Markovnikov, and according to anti-Markovnikov, negative part will go to that carbon which has greater number of hydrogen, and this will come to this. So this is the reaction. Okay.
Yes, sir.
Please write. So this is it for today. I will see you tomorrow at the same time, and we will have a test tomorrow. Do you have any doubt?
No, sir.
So please try to understand this organic part is very important. You know, you have to study on regular basis. What is the reagent, what its name, and everything. In the next week, I will extend our classes. So this is it for today.